right, as we continue, we are now going to move away from most of our plus, minus, times. And notice there it was always a, x, where it was just something general. Now something else changes. Now we have a number here. Okay, what's that going to change in things? Well, in our case here, we have a composition first. So we have the little o. And when we do that, we work our way backwards. So my first job here is going to be to find h of 5. In other words, I'm going to take 5, I'm going to plug it into h. So negative 2, let me grab a color here, 5 squared minus 2 times 5. Now you can type that into the calculator. Some of you, I'd actually suggest that just because we got to follow order of operations here. We square the 5 first, which would be 25, and multiply by 2, 2 times 5. Okay, but I'm not done. That's just this first part of plugging 5 into h. My second job then is to plug that answer into g. So I'm just kind of working my way to the left. So here's g, negative 3 times negative 60 plus 2. Okay? Negative times negative is a positive 180 plus 2 is 182. The only time I have to do two completely separate things like this is when it's a composition, when it's the little open O there. Okay? So like for f minus g of 5, you plug 5 in for the t's, you minus the two things from each other, just like we did up in number 19. And so on. However, so for instance, let's look at 24 for a second. This, f times g of 1. I could do a box on this and then plug the 1 in. Okay, that would absolutely work. Okay, you could box, then substitute negative 1 for a. That would be legit. I think personally this would be simpler to say, okay, I'm going to do f of negative 1. So I'm going to plug in negative 1. The a's are enough. I'm going to plug in the negative 1 where the a is in my g. Negative 1 squared would be 1. Minus 2 is negative 1. Negative 2 minus 2 is negative 4. And you multiply them together. I think that goes faster. Now again, it's not about speed, it's about accuracy. So if you wanted to do your box or your FOIL and then put the negative 1 at the end, you could. Once we get there, okay, we're going to be doing our factoring. Again, your blue sheets are okay to use. If I have 4 terms, I'm going to, pair those off. And I'm going to look within each pair for their greatest common factor. Now that can be coefficients, that can be variables, that can be, in this case, both. 2 and 14, 2 divides into both. Into the third and n squared, I take the smaller of the two. And once I do that, okay, 2 times what gets me to 2, okay, 1. I got 2 n's, I need to get to 3, so I need 1 more. 2 times what gets me to negative 14, negative 7. And I already have the n squared. So here's the key. When I do my second one here in a minute, my parentheses at the end have to be the same. So here I look and I'm like, okay, they got 3 in common. So I start looking, I'm like, ooh. Now right now, 3 times what gets me negative 3n, I'd have to put negative 1n here, but that's not the same. So I'm like, okay, I wonder if negative will work. Negative 3 times what gets me negative 3n, just the n. Negative 3 times what gets me positive 21, negative 7, and I notice they're the same. So then to get my answer, I take the greatest common factors that I took out, and I take my common set of parentheses. I do my grouping, and I'm done. So my 4-termers, pair them off, find the pair, work it. If I need assistance when I get to the next part, and maybe I do, I'm going to take a peek, though. I'm always going to look first to see if there's something that divides in, maybe, or something, or maybe I look for clues, like if this is a 3 or a 2. Because with my 2-termers, okay, I'm seeing, well, this could be a sum of cubes or a difference of cubes. How do I know? 27 and 64. 27 and 64 are both in my list. Okay, 3 cubed is 27, 4 cubed is 64. So I'm going to write down what I need to cube to get each of these. And again, the more you use the sheet, the more you're going to get used to seeing these numbers and working this easier. And at this point, I'm going to use my sheet. I'm going to go, okay, it's minus in the middle, so it's a difference of cubes. So first minus second. And then I square my first term, the 3 and the u. So this is what I was actually doing there, squaring the 3 and the u. This is plus, multiply your 2 terms together. 3u times 4 is 12u, and square your last term. And that's it. Okay? But I have to be able to find these values to be able to plug in. But otherwise, you're just doing the form. You're just substituting. You're not doing anything fancy. Okay, so as I keep doing these, as I do one, let's say, like 30. Now I look at 30, I'm like, okay, there's the cubes again. Oh, but 108 and 32 aren't in the list. Okay? Remember, don't give up on that yet. Do they have anything in common? Does anything divide into 108, and 32? Now I may have to play with this a little bit. So let's say, I don't know, let's try 2. Whoa. Making some crazy stuff. No. Okay. So we're 54 and 16 on my cube list. 54 and 16. No. All right. Well, maybe if I try a bigger number. 108. Let's try 4. 27 and 8. Ooh, 27 and 8 are on my list. Okay. So if I take out a 4, we got 27 and 8. And now I'm basically going to take what's in the parentheses and I'm going to do the exact same thing that I did in 29. What do I cube to get my first term? What do I cube to get my second term? Now that 4 I took out does not disappear. It just ends up at the front. And again, I'm going to take my patterns, once I get them to fit on the screen. There we go. This time it's a sum. So it's first plus second. Square my first. We talked about that in the last one, the 3 and the u. This middle sign becomes a negative. I multiply those together. And I add the square of my last term. Nothing different. I just have to start working at finding the common term before I get there. And then finally, 33. I start looking again. Okay, 2 terms, but now it's squared. Okay, so squares. Let's see, 20 and 125. 20 and 125. Not in the list. Maybe there won't be something, but I sort of start to look and I'm like, ends in 0, ends in 5. It might be a good idea to try 5 out with each of these. So let's try that. 4 and 25. So 5, 4b squared minus 25. 4 and 25. All right. Now, this is not going to be as large as when I was doing my cubes a minute ago. When I've got my difference of squares, it's just first plus second, first minus second, but be careful. Not 4b and 25. What do I square to get each of those? I square 2b and I square 5. 5 squared is 25, 2 squared is 4. Then I'm ready to do first plus second, first minus second, and I'm done. You've got to follow your rules. And if you haven't practiced, you need to do a lot of it in short order here, people. Okay, find the inverse of the function, switch x and y, and solve for y. Okay, so remember, f of x is a fancy way of saying y equals. So first job, switch x and y. We are solving for y. Now, when we did this on the last quiz, there were some parts that were good and some parts where we struggled. So let's chat about this. First job is I got to minus this 3. Not negative 3x. I'm not multiplying. I'm subtracting. Here's the point where some of you got hosed, but you did it to yourself. Do not divide both sides by 5/4. About 98% of you don't know what that means, and then your answer doesn't look at anything correctly. So here's what we're going to do. We're going to get rid of the fraction first by multiplying by 4. Okay, that's the 4's only job on the right side. On the left, that 4's got to go to both terms. So 4x minus 12. And now I can divide by 5. And I don't care if you leave it as a big fraction. Now, if you were graphing, that's probably not the best idea because it's going to make it trickier. Or you can leave it in fraction form. I don't care which. Okay? But work on isolating and getting rid of your fraction. We've got to do it. Same thing on 35. Switch. Now this time it's a little different. I got to get rid of the fraction first this time because that's the only way I can deal with this stuff. But just like before, we're going to do things one step at a time. Get that fraction out. Now I'm working on getting my y term by itself. So it really comes down to you trusting yourself as you're doing these. And again, that's fine. Or if you divide each piece individually, you can get that too. But you've got to switch x and y and then slowly, step by step, not trying to do multiple steps at a time, isolate your variable. Okay, and here's our other Achilles heel from the last one. Are the functions inverses? Does f of g of x equal g of f of x? Okay. Pieces, people, pieces. G into f. Okay, not going to be a lot of fun, but we're going to make this work. So, I start writing f. When I get to x, I replace x with all this crazy business. Now, before you go into a panic, that you now have a fraction over a fraction. Let me put you at ease. Okay, all you see what I did? I plugged g into that little spot there. Here, the 9s are going to cancel. Okay, so I'm not going to have to worry about that. But the negative that's there, I'll still distribute. So let's see what we end up with. Negative 20. Negative times negative is positive 5x. Negative times negative is positive 20 over 5. Negative 20 plus 20 cancels. 5x over 5 equals x. Okay, we passed step 1. If I get x, that's what I'm hoping for. So now, I got to switch and do the other one. Now, if I wouldn't have gotten x for the first one, if I got negative x, x plus or minus a number, I'm done. It's no. But I didn't. So now, we're going to do it the opposite way. We're going to start writing with g until we get to x. And we're going to do the same thing. And just the same way that it did in number 1, my 5s will cancel, but the negative's still there to distribute. And again, this is an extreme. That's why I'm doing this one with you. Just so you're like, okay, this isn't terrible. I can do this. So I get to here and I go, okay, so I got 20. Opposite is plus 9x minus 20 over 9. The plus and minus 20 cancel. Those are all good. And we get a yes. And so I just kind of have to keep working those this way until I see what's happening. Now let's say I get going here and I'm trying 38 out and I'm like, okay, I got this one. G into F. Okay. Negative 4. Okay, there's my x that I'm replacing with this stuff. Everything else is still there. The only thing I took out was the x. So I distribute. Find my like terms. And I take a look, I'm like, that ain't x. I don't even have to do the other one. Okay? If that first answer is not equals x, functions are not inverses. Okay? Just taking a look at that way. So we keep rolling here. Okay, graphing was a spot we ran into an issue. I'm actually going to do 42 here. So up at the top it says find the inverse and then graph the function and its inverse. Okay, so that's one of them we're going to graph. Now the inverse, switch x and y, solving for y. So get that set. Just like we said before, get rid of your fraction. In this case, that's going to take care of everything for me because 1y and y are the same thing. Make sure I distribute my 2 through. So I have 2 lines that I need to graph. And again, I'll show you different ways you can do this. So let's say I'm looking at my one I found an inverse of first. Okay, this is a slope-intercept form. This is my y-intercept. I could go down to negative 6, put a dot, and then go up 2 and right 1. Up 2 and right 1. And if you're comfortable with graphing lines, that is a solid way to go. But let's say you're not. Let's say you're like, Harty, me and graphing lines, I get the x and y intercept confused. I don't even know where to start. Okay. So let's say on the second one, you decide that you're just going to plug it into the calculator. Now, again, if you do that, you've got to make sure you got parentheses around your fraction. At this point, you could go to second graph, and I seriously, we got to do what we got to do. I would go through then, and mainly just using the whole numbers, I would go through and get my graph. And be done. Okay? Calculator to get you there. Slope-intercept form knowledge to get you there. Either one works for me. Okay? But again, if graphing is your Achilles heel, find something to help you. All right. Now to the stuff we've been doing. Is the given binomial a factor of the polynomial? Use synthetic division to prove it. Okay, remember, opposite of my binomial, I'm going to use 5. Do I have any gaps? 3, 1. Oh dear, very first one, we got a gap. Okay, 0x squared. 3, 2, 1, 0. Put in my coefficients. Okay, again, drop my first term down. Then multiply that by what's in the box. And add down. Multiply what's in the box. and add down, multiply by what's in the box, and add down. And again, I know this is what I'm looking for, but just again, to be proper, we go down 1 degree from each, 2, 1, 0, and there's my answer. If I would have gotten any value other than 0, then we'd have said, no, that's not a factor. And that's all we basically are looking at with these, okay? But watch for those gaps, too, when you're in there. We've talked about that several times before as well. All right, we're getting there. Hey, some good news. 47, 48, 49. Skip, we're going to cover what we need here on these on the last problems in here, and we didn't do the increasing, decreasing. So just kind of give up to 47 through 49 there. Divide, use synthetic division. Same as what we just got done using for our factors. Flip the sign of your divisor. Negative becomes positive. Do we have any gaps? 3, 2, 1, 0. Nope. So I get that done. Drop my first term. Multiply. And add. Watch your signs. Multiply and add. Multiply and add. So if we're looking to see if this is a factor, we know the answer is no because I have a remainder. But I also have to put my variables back in. I started with a 3rd degree polynomial. I'm going to go 1 less than that. 2, 1, 0. Gotta put the fraction for my remainder. You can't just leave it as plus 8. You can't put R8. Whatever you were dividing by becomes the fraction of your divisor, okay, of your remainder. Now, that's synthetic. They're like, uh-oh. Long division, okay? This is where we kind of get on a roll with things. We got to do our step process. This is the one where we had kind of some side work working here. So I look and I'm like, okay, x minus 6. No gaps, thank goodness. Okay. And again, if it's been a while, this may be good for you to see a couple done. So my first job. First term under the division sign, the 2x to the 3rd, divided by my first term outside. 3 minus 1 is 2. Okay, that's the first piece of my answer. I then am going to use that value, the 2x squared, times my divisor. So the 2x squared is going to distribute to both of these. Add my exponents. Multiply my coefficients. And here's where I may say something a little different than we've done before. I've been talking with some of you that struggled with this on the first quiz. And your deal was, my problem is, Harty, you tell me that when I'm doing this, and I'm going to do it on a Post-it note here at the start, that I write these underneath here, and just kind of watch for right now. And then I got to subtract. Well, I'm good on the first ones, but then I forget here because I just got done doing synthetic division, and that's add, and I get negative 22, and I'm all messed up. What do? Okay. If you nailed this the first time, keep the minus there. Remember that it's distributing through, and you'll get your answer. If that was a struggle, let me give you a suggestion. We know we're going to subtract here, okay? And that means the signs on these are both going to switch. So if you want, we can switch the signs on both of these when we bring them over, and then just add down. So if the minus out in front is what's messing you up, switch the signs on both of these. Those will cancel. And I'll add down, and I'll end up in the right place. So once we do that, we start the process over. This is now my first value. So I get that done. I take that, multiply it by my divisor, add my exponents, multiply my coefficients. And again, if you're comfortable with the subtracting, write that, put the minus in front. If not, we're just going to change the signs on both of these terms. First terms will cancel. Negative 18 plus 12 is negative 6x. And I got to do this one last time. Why? Because I still have an x. And again, if you didn't do the homework on this the first time, maybe you do a few more that way to kind of get you into gear here. So my last one, again, go with your format. I can switch signs on both, or I can do the minusing. And so that's 6. Don't just leave it down there. Okay, that's my remainder. Plus 6 over x minus 6. No canceling, no reducing. That's what I've got to do. And if you need to, you go back and you type on the website long division, or you look at your notes or something like that. Don't leave that blank. It's a 3-point question because there's a lot of stuff that you need to do. Okay, so practice those. Come and ask some questions if need be. All right, folks. Here comes the end. What we just got done with. And notice I added a little small instruction here. Sketch the graph of the function, approximate the relative minima and maxima to the nearest tenth, and find your x-intercepts. Okay, so we got one that we're going to do back here. Which one are we going to do? Oh, we'll do 56. All right. Get my y equals up here. Get my... And as I'm getting this typed in, remember, with all these ones that we haven't done together, I've posted the entire review key online. It's also in class. But try to do them yourselves first. Don't just copy them and then think you're good, because that's usually a recipe for disaster. Okay, so I get to here and I go, all right, x-intercepts. That's what we're going to look for first here when we're trying to get these set. I'm going to look at my table first. See if I get lucky. Do I get any freebies? I don't get any freebies. Well, what the heck. Second trace. We're looking for zeros. So I'm going to get as close as I can to that first one. And now you've heard me say this so many times, it should be like second nature. So we're going to go 1, 2, 3, 4 to the left. Hit enter. There's my first border. 1, 2, 3, 4. Get back where I started. 5, 6, 7, 8. Trap has been set. Borders on both sides of the value I'm looking for. Get that 0. Okay, so negative. Oh. That wasn't even cool. Okay, I'm going to do this really fast since I lost my value here. Okay. Negative 0.0009. Didn't round right. 0, because again, we've got that there. I'm going to kick it into gear a little more on these last two. Again, get as close as I can. 1, 2, 3, 4 left, enter. 1, 2, 3, 4. 5, 6, 7, 8 right. Trap set. 2.570. One more time. 0. Close. 1, 2, 3, 4. Enter. 1, 2, 3, 4. 5, 6, 7, 8. Lucky thing, you can pause me when you're at home if you want to, if I start whipping along here too quick. Okay, so I've got my x-intercepts, all three. Okay. For my min and max, I notice I've got one valley and one hill. So let's do our valley. Back down here to the bottom of the valley. But the rules are the same. 1, 2, 3, 4. Enter. Right. 1, 2, 3, 4. 5, 6, 7, 8. Enter. Trap's been set. Find that min. 1, negative 6. And finally, yes, you will have survived. Go find that Go find that mountaintop and holler off of it. Woo! We almost done. All right, up to the top. Left. 1, 2, 3, 4. Enter. Right. 1, 2, 3, 4. 5, 6, 7, 8. Trap set. Max. Show us where you are. And of course, I see now that I said it, I told you to go to the nearest 10th, which I didn't do. Bad, Harty. So I'm going to plot these values as best I can. And then I'm going to use my calculator as my guide here to get that drawn in. All right, ladies and gentlemen, you have got the load here. This is it. Again, the test itself is not this many questions, okay? The test itself, as I take a peek myself here, is like a little less than half of this. It's going to be 28 questions. If you're ready, you will get done. If you are not ready, you will not. So take advantage of this, look things over, practice, 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 and be ready to roll.